Okay, now let us look at some questions, and also they will involve some techniques of how to find out the LCM or HCF in the question. So it says I have 3 containers containing mixtures of 403 kgs, 434 kgs and 465 kgs. Which is the biggest measure that can measure all 3 quantities exactly? So this simply says, let me just try to make you understand the question. So this basically means if let us say my measure is equal to m, then this measure should be able to divide this completely. That is how it will measure this 403 kgs. It should also divide this completely. It should also divide this completely, which means m is simply the HCF of these 3 numbers, because m is dividing all these 3 numbers completely, which means m is a factor of all these 3 numbers. Now how do I find the HCF of this? One way of doing this is to start doing the prime factorization of these and trying to find out, but there is a simpler way. I told you that if the HCF of A and B is H, then H is also going to divide A plus B and A minus B. So let us try to use this property here. So if HCF of these is some number H, now let me take 434 minus 403. What I get is 31, which means the HCF should also divide 31. Now similarly, if I take the difference of these two, I also see that this is also equal to 31. So this means that the HCF is 31 itself, because if that number 31 divides this number, then that is going to be the HCF. So you see that this is indeed divisible by 31. So in this case, because the answer 403 divided by 31 is equal to 13. So I know that 31 is going to divide all these 3 numbers. My HCF is simply 31. So whenever you're trying to find out HCF of large numbers, first take the difference of the 2 numbers. Also check if it is also the difference between the other 2 numbers is also either this itself or a multiple of 31. Then this number will be the HCF if it is dividing, let us say, one of these numbers. So that is important, how to find out. So the biggest quantity that can measure all these 3 quantities will be 31. This is my answer. Now it's asking me the least number of square tiles required to pave the ceiling of a room which is 15 meter wide and 9 meter long. So let me draw, let us say this is 15 meters and this is roughly equal to 9 meters. Okay, it's slightly off. Maybe this is more like it. So this is 15 meter and this is 9 meter. Now it says least number of square tiles. So which means if the number of tiles are to be least, the measure of the tile should be the largest. That is how the number will be the least. So let us say if I take a tile equal to 9 by 9. So what will happen? The tile will cover here completely and it will cover, this will be my tile of 9 by 9. But if this is 9 meter, how much is this left? This will be 6 meter. Now if I try to put the second 9 by 9, this is only 6 meters left. My tile is 9 meters, so it will end somewhere here. So this is how it will come. Obviously it is not going to be proper, so I cannot be using this tile. So which means that it cannot be 9. So what I am trying to tell you is, if this is a side of 15 meter, so whatever the dimension of the tile is, it is going to fit this completely. So if let us say I put tiles of 5 meters, then it is going to be like this is going to be 5 meter, then this is 5 meter and this is going to be 5 meter, and hence it is going to fill this side completely. But if I take any tile dimension which is not a factor of this 15 meters, then what happens? So again let me draw 15 meters here. So now let me say that instead of taking a factor of 15, let me take, let us say for instance 6 meters. If I take 6 meters, what happens? So this will be the first 6 meter. Okay, then I have another 6 meter that will come here. This is 6 meter. This area totally covered will be 12 meter. How much is remaining now? Only 3 meter. I cannot put a 6 meter tile here. So what I'm trying to say basically is that in these questions, if I have to find the square tile, the dimension of the tile should basically be a factor of both 15 meter and by the same logic it also has to be a factor of 9 meters. So the dimension of the tile is basically equal to the highest common factor of 15,9, because then the dimension of the tile, because it's a square tile, it will divide 15 also completely and 9 also completely, and that is how the number of tiles will be the lowest. Now in this case we all know that the HCF is equal to 3 meter. So my tile has to be 3 meter into 3 meter. Now in case you were also asked how many such tiles are used, how many tiles are used to pave it completely, in that case we will take the area approach. The ceiling of the room is 15 into 9, so the area of the ceiling is 15 into 9. The area of the tile is 3 into 3, so the number of tiles is number of tiles required into, basically I'm filling the area completely. So this is the ceiling. What I'm doing is I'm taking, this is 3 by 3, this is 3 by 3, this is 3 by 3, so this area gets filled, and similarly this is how I'm going to fill the whole ceiling. So the area gets filled completely. You can actually just count in this case 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 tiles, but we need to find it out using a formula because you may have larger numbers. So the area of the ceiling completely filled by 3 by 3 tiles. So the number of tiles is simply 15 into 9 divided by 9, which is equal to 15, which we also found out by simply counting. This is how you do these questions. Now the third question is, two baskets contain 95 and 120 mangoes to be distributed in equal number. So we need to distribute in equal number. Find the largest number of mangoes that can be given such that 5 mangoes of the first basket are left over and 10 mangoes of the second basket are left over. So this means that out of 95 I am leaving over 5 mangoes, which means that I have 90 mangoes for distribution. Similarly, out of 120 mangoes I am leaving out 10 mangoes, which means I have 110 mangoes for distribution. So now this question basically means that I am making sets of a particular number. So 90 mangoes have to be divided in sets of that particular number of mangoes, and so is 110. So this is basically just the common factor of 90 and 110. In this case this is equal to 10. So this means if I make groups of 10 each, how many groups of 90 mangoes will I make? I will make 9 groups, and similarly here I will make 11 groups, and I cannot find a larger number than this, so that I can be dividing these two in equal number of, the group will have the equal numbers.